This is the second video on rationalising the denominator of various algebraic fractions. Compared to the previous video, you'll see that the denominators look a little bit more complicated. Each denominator is the sum of two terms. We've got a rational part, shown in green, and an irrational part, shown in red. Now, you should be comfortable with topic N8b, and if so, you'll have a very good idea about how we're going to deal with these. In fact, pause the video and have a go at this recap question. Hopefully, you've remembered how to do this kind of question. What you want to do is multiply the numerator and the denominator by the conjugate of the denominator. Now, the conjugate of the denominator is simply the denominator that you've got to start with, except you change the sign of either the rational or the irrational part. So in this case, a conjugate of 5 minus root 7 would be 5 plus root 7. That means we need to multiply the numerator by 5 plus root 7 and the denominator by 5 plus root 7. If we expand out the numerator, we get 15 plus 3 root 7. Now, if we expand out the denominator, we're going to get 5 times 5, which is 25. We're then going to have 5 times positive root 7, which gives us 5 root 7. And then we have negative root 7 times 5, which means we need to subtract 5 root 7. And then we have negative root 7 times positive root 7, which gives us minus 7. Now, notice that these two terms add up to 0. They cancel each other out. So the denominator simplifies to 25 minus 7, which is just 18. And our numerator is 15 plus 3 root 7. We have rationalised the denominator. Notice we don't have a square root in the denominator. So the key skill for this video is to rationalise the denominator. We simply multiply the numerator and the denominator by the conjugate of the denominator, and the conjugate of the denominator is simply the original denominator where either the rational or the irrational part has changed sign. So in this case, instead of 5 minus root 7, I've got 5 plus root 7 for the conjugate. Okay, let's get back to the examples. Looking at the first one, you can see how it's more complicated than the examples we saw in the previous video, where we would have just had something like root x or 2 root x or something like that. But because we've got this plus 1 here, it makes life a little more difficult. So this is one of those situations where we want to multiply the numerator and the denominator by the conjugate of the denominator. To find the conjugate, all I need to do is take that denominator and change the sign of either the irrational part or the rational part, but not both. So the easiest way in this case is simply to multiply that by root x minus 1. And to keep this fraction equivalent, I need to multiply the numerator by root x minus 1. Now, multiplying that out, I get a numerator of 2 root x minus 2, and my denominator is going to be root x times root x, which is x. I'm then going to get root x times negative 1, which is minus root x. Then I'm going to get 1 times root x, which is plus root x. And then I'm going to get 1 times negative 1, which is minus 1 there. Notice that these terms add to 0, so they effectively cancel out. So what we have is 2 root x minus 2 over x minus 1. Moving on to the next example, we've got 3 over 5 minus root h. To rationalise this denominator, I can multiply it by 5 plus root h, and to keep the fraction equivalent, I need to multiply the numerator by that same thing. Pause the video and see if you can expand the numerator and denominator here for this fraction. Here's what I get. The numerator is 15 plus 3 root h. The denominator is 25 plus 5 root h minus 5 root h minus h. As we've seen, these add up to 0, so they cancel each other out, and that means we have 15 plus 3 root h over 25 minus h. Here are 2 more questions. Pause the video and have a go at these for yourself. Here are my workings. For the first one, I'm going to multiply the denominator and numerator by 3 minus root m. That gives me a numerator of 3 root m minus m. And for the denominator, I'm going to get 3 times 3, which is 9. I'm going to get 3 times negative root m, which is negative 3 root m. But then I'm going to add 3 root m. So those will cancel each other out. I'm not going to bother writing those in my denominator here. And then we've got root m times negative root m, which is minus m. So I've skipped a step here because we're always going to get those 2 terms that cancel when we multiply by conjugates. And we've got our answer. It's 3 root m minus m over 9 minus m. For this next one, the conjugate we need to multiply by is going to be b plus 2 root a. And because we multiply the denominator by that, we need to multiply the numerator by the same thing to keep the fraction equivalent. So, multiplying out this numerator, we get a times b, which is ab, plus a times 2 root a, which is 2a root a. Then we multiply root b times b, which gives us b root b. And then we multiply root b times 2 root a, and that gives us 2 root a root b. Now, we could combine root a root b into root ab. And in fact, I'm going to do that right now. Now, the denominator here is going to have b times b, which is b squared. We're then going to have b lots of 2 root a, but then negative 2 root a lots of b. So those 2 terms will cancel each other out. And then we'll have negative 2 root a multiplied by positive 2 root a, and that gives us minus 4a. So there we have it. We have written this fraction with a denominator that does not have any roots in it.